Now I'm very pleased to introduce our next Polish speaker. Please welcome Dr. Kamila Sałasińska. I'm happy to delight to have you here on stage to talk about biocomposites important from biofillers to bioadditives. Welcome.
Thank you very much. Good morning, my name is Kamila Sałasińska. I work at Warsaw University of Technology at Faculty of Material Science and Engineering, which is a member of Polish cluster of composite technologies. And today I would like to give you a short presentation concerning situation of biocomposites in Poland and current approach. Warsaw University of Technology is one of the oldest and biggest technical university in this region. However, my faculty is the smallest faculty from the whole uni. I work in an advanced polymer matrix composite group established by Professor Boczkowska, who now is the dean of this faculty. So my presentation will be more from academic than business point of view. However, I hope that it will be interesting for you. When you put biocomposite word in a science direct base of knowledge, you will find a lot of articles and books with different definition. Even if this publication, you can find statement that depends on the publication, the definition can vary. So, as a biocomposite, we can treat a natural fiber reinforced biopolymers, which was developed as an alternative to conventional non-renewable materials. Or, as a biocomposite, we can treat biocompatible or eco-friendly materials, which can be treated as eco-friendly composites, or can be used in a biomedical application. Also, as a biocomposite, we can treat material which is composed from at least two materials, one of which is naturally derived, and we mix them to achieve mostly a new material with better mechanical properties. This definition is close to definition proposed by AI, which is quite good and best, I can say, compared to Wikipedia, for example. I choose one which is more connected with my knowledge, and based on this definition, as a biofillers, we can use, for example, part of a lignocellulosic plant. However, because it's quite low thermal stability, we usually use polymers with quite low processing temperature, for below 200 Celsius degree, and can mix them with non-bioderivatives polymers or with bioderivatives, also in some cases biodegradable, or we can also mix non-biofillers with biopolymers. So depending on the composition, we get biocomposite which can degrade in a specific condition in a composting plant or not. We can produce them using different well-known techniques which are used in the case of polymer composites field. However, we usually try to produce new biocomposites to replace the well-known synthetic composite. Unfortunately, natural fibers cannot be employed as reinforcement in the same manner. We have to accept it that they have a different sensitive to heat and humidity because of different microstructure and also because of the different chemical composition. So we have to accept their natural variability. We have also other issue connected with economic and environmental challenges. For example, we usually say that Biocomposites have a lower environmental impact because of photosynthesis and process, and also because of reduced carbon footprint. However, it's very important what we do during their whole life. For example, important issue is waste management or some modification. Other important issue is some processes which we use during the cultivation to minimize the heterogeneity of our plant. Also, we use a lot of water and lost some biodiversity. Other issue is that this industry, unfortunately, will always compete with agriculture, biofuels, and textile industries. Also, bio-based resin are produced usually in small-scale facilities with a complex supply chains, and which influence on the prices and also on the quality. In this case of natural fibers, also, unfortunately, we have to agree with some seasonal functionalities, which influence on strength and density of the final product. So we have to use some modification or use some additives. And one important issue, because usually we produce our natural fibers using quite old, well-known techniques, so they are moved from east to west part of the world, so we have to also add the transport and lower quality usually. The authors of this publication arise also other, I think, very important issue. We have a lot of publication concern the properties of the final product of composite, which, for example, natural fillers with laminates. However, only few of them are linked with the basic properties of used fillers, for example, with the chemical constitution or microstructure of them. So this is a gap in the knowledge. Fortunately, the manufacturer use their own experience usually, or they made a lot of trials or add a lot of modification and additives to get the final product with the desired feature, which can be used in a different sector of economy to reduce the environmental impact, weight, carbon footprint, also to increase the aesthetic function of the final product. I divide producers in Poland in 3 groups. The first one is natural fillers suppliers. For example, Safilin is a European flax and hemp spinning mill with factories located in Mazur in Poland. We have 3 companies there. They produce rowing and textile reinforced for the biocomposite production. Other group, granulates. In this group we have a manufacturer of polymer natural fibers, granulates for production of different type of customer goods, which can be found, for example, in IKEA, but also the largest group, producers of composites, mainly laminates, for example, to produce their final product, like the company presented on the slide for a luxury catamarans, which use flax or flax with basalt fibers textile to produce their final product. Apart from quality issue, have also issue connected with the price, and I would like to show you how the price of composites and wooden board changed over the last decade in Poland. 10 years ago, the price of composite and wooden board were much higher compared to traditional wooden board. Next, during the pandemic, the time the price were, we can say, similar. Next, because of the war, the prices stabilize. However, they are still higher compared to time before the pandemic, and now we can say that the increase has slowed down, but still is quite high. So, about 20 years ago, when I start my journey with the natural fiber composites, I would like to buy some composite for my balcony. However, it was impossible because of the high price. Still is quite expensive. I am a science. However, I know that it's expensive not only in Poland, but in a different part of Europe. So what can we do? We should reduce the price, reduce the quality of the product, go to use waste instead of wood, for example, which is quite expensive, or go to the high quality new product with a lot of modification or additives. Definitely we should go green, or as my favorite professor said, eco-nonsense. However, he also knew that is a future. I would like to show you a few examples of product which we do now in Poland. We used to work in the case of polymer composite, biocomposite. Now we more specify our work, focus on some special features of plant which could be beneficial for the final product. And this is example of the project due in Poznań University of Technology. My colleague used a waste filler of plant origin with some functional properties to self-stabilize wood polymer composite. They use some specific plant, for example, coffee or some walnut shell with antioxidants ingredients to increase the oxidant resistance of the final product. The same group using also thermal or thermomechanical modification to prepare new fillers for natural fiber composite, which can be used in thermoplastics, for example, with a higher processing temperature. I also use these fillers for my project. In this project, because I am involved in a flammability reduction science, so in this project, because as a polymer I use polyamide with a quite high processing temperature, so I have to modify my fillers, and we use thermal treatment, during which we change the chemical composition of the plant, and from flammability reduction point of view, it's beneficial because I reduced the use of the content of more flammability ingredients like oil or waxes, and increase the content of cellulose and lignin with a lot of hydroxyl group, which because of the phosphorylation lead to the formation of a char layer on the surface of the materials. This research field was developed based on our previous research, based on which we introduced some walnut shell or husk to epoxy resin, and observe that it produces some char on the surface of the materials, which reduce the heat release, but also influence on the emission of gases and its toxicity. However, they cannot be treated as a commercial flame retardants, but also to increase their effectiveness, so we combine them with a synthetic one. This one was developed by my colleague. It was based on histidine, And we observe that after the burning process on the surface of the materials, the 10 centimeter char cover was built, which reduced the history rate compared even to commercial solution from the market. And we also observed that the combination of specific plant ingredients with some synthetic flame retardants may even change the mechanism of action of this synthetic flame retardants and especially increase their effectiveness. We continue our research in some European project. In this project, I will be involved, especially in the flame retardants reduction. We also will develop a new flame retardant system for composite with the Vitrimer matrix. And to conclude, definitely go green. However, remember that we have a gap in the knowledge, so please first characterize your fillers and link this knowledge with the final properties of the composite, because probably you will find some beneficial additional features which lead to the reduction in the synthetic composite, and you can also increase the sustainability of your final product. Thank you very much.
Thank you very much, Kamila, for your exciting presentation. Kamila Sałasińska, thank you very much. And now I would like to open the audience for one question, because we have some time.
Please feel free to chime in. There's a question from Peter, yes? Peter, the microphone, please.
Microphone. Yeah. Okay. Thank you very much for this nice presentation. You were talking about flame retardant fillers. Was it in normal plastic, or was it in also bioplastic? Could it be also used in bioplastic like PLA and PBS?
Probably it will be even better. Because of the chemical constitution of this bio-based plastic. However, at this time we focus mainly on epoxy resin, because they have very high flammability, especially, and they are used in composites. Now we also in polyamide, because of its use in electrical application, for example, and now we start our new project with Vitrimers. We check it and it works.
Okay, if you need some support, please, we can help you.
Thank you very much.
That would be also my question. However, might be a very good linkage to biopolymers of this audience. So it sounds very promising. Thank you so much for your presentation.
Thank you very much. Kamila Sałasińska.